Here's problem 3118. A conducting rod length 2 meters spins at a constant rate of 2 revolutions per second about an axis that is perpendicular to the rod through its center. A uniform magnetic field, magnitude 8 millitesla, is directed perpendicular to the plane of rotation. What is the magnitude of the potential difference between the center of the rod and either of its ends? If we're going for a rod of this nature, where its total length is 2 meters, the L in question from the center to the end is going to be half that. So the L that we're talking about here is 1 meter as this helicopter blade spins around. So we're going to use an L of 1 meter. We have a magnetic field directed perpendicular to the plane. Let's go in like this. That's 8 millitesla. And we need to know the angular velocity. That was given as 2 revolutions per second. We need to convert that immediately to radians per second. So we multiply this by 2 pi radians per revolution. Revolutions cancel out, so this is equal to 4 pi, and that's equal to 12.57 radians per second. So that's our omega, angular velocity. We have our L, we have our magnetic field. Hence, the induced EMF for this helicopter type problem is the magnetic field, angular velocity, length squared, divided by 2. That's going to be equal to 8 millitesla times the angular velocity of 12.57 times the length of 1 meter squared, all this divided by 2, and that's equal to 0.0503 volts. Or we could write that as 50.3 millivolts. So we will induce a voltage between the end, or the center and the end of this rod of 50.3 millivolts.